Let's go over problems 10, 14, and 16 on Chapter 12, Section 2. For problem 10, we will do the 8-step process. Number 1 is to find the claim. The claim is given. If we read through that the three size categories have the same mean pelvis injury measurement. So our claim will be that mu1 equals mu2 equals mu3. The opposite of that for number 2, probably want to write claim up here. The opposite as is that all the means are not equal. At least one does not equal the others. For step 3, our null hypothesis is our claim, so we can rewrite the equality statement. Our alternate hypothesis is the same as what we wrote for the opposite in number 2, so you can rewrite that. For step 4, alpha is 0.05. Step 5 lists the test statistic we need to use. That is the F test statistic. The test we will be using is the ANOVA test. Step number 6, we will compare. We are given the information in the Excel stat box on page 612. So the F value that is listed is the F test statistic, and that is given as 0.3476. The test statistic is the value that's calculated. So unless it says critical value, as it did in problem 8, you can pretty much assume that the F value shown on that output screen will be the test statistic. The last column to the right is the p-value, and that is 0.7111. I'm not quite sure what the PR greater than F is. I'm not familiar with the Excel stat program, but that is the p-value that's given there. Number 7, I'm going to compare my values. I will use the p-test, so the p-value is greater than alpha. I'm not going to mess with calculating the critical values for F because I don't need to do that, so it just asked me to test the claim, so I only need to do one of these tests. P is greater than alpha implies that I will fail to reject the null hypothesis. If I fail to reject and my original claim included equality, as this one does, then I will use the wording for number 4. And for step number 8, write something like, there is not sufficient evidence to warrant rejection of the claim that the 4 treatment category, that's the wrong one. There is not sufficient evidence to warrant rejection of the claim that the 3 categories of cars have the same mean pelvis injury measurement. After step number 8, you're asked to answer a question. Does the size of a car appear to affect pelvis injuries? And we will say no. The size of a car does not appear to affect pelvis injuries. And because we failed to reject the original claim, we failed to reject equality. Therefore, equality is still a possibility. So the size of the car does not matter in this case for this problem. And that's it for problem 10. Moving on to problem 14. In this case, we will need to calculate the values ourselves using our calculator. But let's start with step 1 and find our claim. Our claim is that the 4 treatment categories yield poplar trees with the same mean weight. So in this case, we have 4 mean values to compare. So our claim is that mu1 equals mu2 equals mu3 equals mu4. Step number 2 is the opposite. So the opposite of the claim is that the means are not all equal. at least one of the means does not equal all the others. At least one of the means is different from all the others. Step 3, our null hypothesis will be equal to our claim, and our alternate hypothesis is equal to our opposite statement. Whatever you answered for number 2, you can rewrite here. Step 4, we're given an alpha of 0.05. Step 5, we are using the F-test statistic, and it's the ANOVA test. But we need to put the data in. So for step 6, we will calculate these values. So for the no treatment, I would suggest entering that as list L1. So there are 5 values with that under no treatment. You will make another list for L2. You can enter the fertilizer data beginning with 0.92. Irrigation, make L3. Fertilizer and irrigation together will be L4. So you enter the 4 lists, and this is also explained, I think, first of all, in the notes from Jack probably, also on page 610. If you look at the light blue box with the technology, it mentions entering the data as lists. Then you select tests. You press stat and tests. You're all familiar with how to do that. And then the very last test to select, it's ANOVA. And I would suggest after you press test, press the up arrow instead of tabbing all the way down. If you press the up arrow, it'll bring you to the bottom of the list first. So then you will be at ANOVA. But regardless, select the ANOVA test. Then something like this should pop up on your screen, the word ANOVA and open parentheses. Then you will enter L1, which you can do by pressing second 1. Then you'll enter comma L2, comma L3, comma L4, close parentheses. Then you go ahead and enter that, and your value should calculate for you. And for this problem, I got an F-test statistic of 0.3801 and a p-value of 0.7687. Being consistent here, I only handled the p-value, and I said the p is greater than alpha, and that implies that I will fail to reject my null. So the wording I will use when I fail to reject my original claim in number 1 is equality. So I will use the wording for number 4. There is not sufficient evidence to warrant rejection of the claim that the 4 treatment categories yield poplar trees with the same mean weight. So I fail to reject that they are all equal. So there's still the possibility that they are equal. So I am asked, is there a treatment that appears to be most effective in the sandy and dry region? And the answer is no. There does not appear to be a treatment that is most effective in the sandy and dry region. And be sure to answer in complete sentences. I know that's what he expects. The last problem in this section is number 16, and that is on page 614. Going through with step 1, the claim. The claim is that the 3 samples are from populations with the same mean. So my claim is that mu1 equals mu2 equals mu3. The opposite of that is that all the means are not equal. At least one does not equal the others. Step 3, my null is that mu1 equals mu2 equals mu3. H1 is that they are not all equal. Again, I can take the wording from number 2. Step 4, my alpha is 0.05. Step 5, I'm using the F-test statistic, the ANOVA test. Step 6, I will go ahead and enter everything into my calculator. So it says to use data set 9 in Appendix B. So go to the back of your data set. There's 3 columns that are 3 lists you will enter, L1, L2, L3. I think each of them had 40 items in each list. I can't remember now. First one is the smoker. The second one is non-smoker exposed to tobacco smoke. The third one is non-smokers not exposed to tobacco smoke. And then I enter those, then I do the test. I do ANOVA. It'll pop up with an open parentheses. I'll enter L1, comma, L2, comma, L3, close parentheses, go ahead and calculate. And then you should get a p-value of, see, I got 1.7911, I think it is, times 10 to the minus 8. Always look for this last part where you have e to the minus 8. Really, if you think about it, the p-value is our area under the curve. In this case, it's the F distribution, but whatever, when we have the normal distribution, the p-value is the area underneath. So it should never just be this. It can never be greater than 1 because the whole area is only 1 to begin with. So when you see your p-values greater than 1, look for the negative exponent afterward. So this is a very small value. I also get my F test statistic, and that is 20.8562. I'm not going to calculate my critical value, but if you look at the table at the back, you can enter your degrees of freedom, try to figure that out. But I have my p-value, so I can go ahead, let's see, that's step 6, my p-value. I did that. So step 7, I have that my p-value is very small. My p is less than alpha, so I reject the null. I reject the null. My claim has equality, so that is wording for number 3. I would write something like, there is sufficient evidence to warrant rejection of the claim that the 3 samples are from populations with the same means. Okay, then it asks, what do the results suggest about the effects of secondhand smoke? So really comparing L2 with L3, L2 is non-smokers exposed to smoke, L3 is those not exposed to smoke, and L2 does appear to have higher values, so you could say something like, let's see, it appears that the secondhand smoke, however you say the word, cotinine levels are greater with more exposure to tobacco smoke, something like that, that secondhand smoke is a legitimate concern. Now, however, there is a note in the answer key here that they do not appear to be from normally distributed populations, which would be part of the requirement, but for the ANOVA test, it's robust against departures from normality. So in this case, it's probably okay. But if you did a scatter plot here, or remember the quantile plots, if we did that using each of these lists separately, I guess that's probably where you would see that the data does not appear to be normal. But again, you may just want to make a note of that when you do problems if they don't seem to meet the requirements. But still go ahead and do the calculations and test your claim. So that's it for those 3 problems.